started. So just a reminder, lab 1 is due by the end of tomorrow. So if you have not submitted yet, please take the time to submit. If you have any questions, email to the email group or stop by my office. I'll be able to help you out. And as I said, lab 1 should be pretty easy. Just for the purpose for you to practice, and you need to make sure that you know how to create a repo, how to clone the repo to your computer, and how to make some changes, commit the changes, push it back, and then deploy automatically. That's what you're going to do throughout the semester, because you're going to build the package and also how to create the documentation. Next week, starting next week, we're going through the step how to create your own Python package so that you can publish on GitHub and also publish on PyPI so other people can install. Today we're going to introduce Google Colab and Jupyter Lab. So those are the two popular tools being used in the data science community. So make sure you know, like for example, what exactly is a notebook, what is Jupyter Notebook, what is Jupyter Lab, what is Google Colab, what is Amazon SageMaker, right? You might have thought about that, but today we want to get your hands on how to actually use that and how to utilize these free cloud computing resources. It's the things that I use not every day, but at least every week. Especially useful if you're trying to teach people how to use your stuff. You're going to utilize those free cloud computing resources, because you're not going to ask people to buy a decent computer just to use your stuff. It doesn't make sense. People are not going to invest money in your stuff if it is not good enough, right? So you're going to just put that on the internet, send a URL to other people, and then they can just run through. So essentially, it's just like Google Document, but just for something for writing code, executing code, so that it becomes interactive. So anyone can run through, they can make changes, and then they can do some computation. So that's the power of cloud computing. And so we're gonna Markdown we actually already cover in the previous lectures. So we're gonna today cover this one and also Google Colab. If we have time, we'll also get into Visual Studio Code. But first, go to resources, and I put some links in here. So these are some of the popular cloud computing resources. Google Colab is the dominant one. It's the most popular one, but Microsoft and Amazon also provide some similar stuff, but it's not as good as Google. And there are also the other two here. We might also use Miner from time to time. So we're going to show you step by step how actually you can use those resources. So let's try out the first one. Just click and then open in Google Colab, or just search on Google. Google Colab, and then you should be able to find the link. So once it's open, it's going to only show you, for example, right now probably if you have never used this before, it's going to be empty. So this is where you can either create a new notebook, so at the bottom right here, or you can just click, look at some of the examples in here. So the best way for coding is don't start from scratch, unless you're like practicing, but always looking at examples, see how other people are doing, and see how you can modify the example to make your own. So here are some examples, and recent is the one like that you have used, and also Google Colab, Google Drive. You can also pull things from GitHub. So we'll show you later, and you can also upload a file, a notebook to your computer. So if you just can you see this tab here, the examples? And let's see here. Maybe look at this one, Trust in Collaboratory. So if you click this one, it should open and load the notebook. So you can think about this is just like you send a link of a Google document to other people, but this is Google Colab that you can share and run code. If you look at this, right, pretty nice. You have some plots, you have some code, you can also have this. So everything here you can actually execute by yourself. You can try it out, you can customize, you can look at the data. Let's talk about the interface. So on the left side here, there's a table of content. So if you click this hamburger sign, the icon, it should hide in this one. So if you want to create a notebook, you also want to have the outline, table of contents. It's actually everything is Markdown. So you can think about Jupyter Notebook is a combination of Markdown and source code. And source code can be Python, can be R. For those of you using R, you can also use Google Colab. So Google Colab also support R. So if you really want to practice, you don't actually need to have a computer to install R Studio. You can write R code directly in here. I will show you later, but for now, let's focus on Python. So if you on the left side, once you open this one, right? This one here, the menu here, right? Code and text, right? Code means you're writing Python code in here. Text actually is just Markdown, right? So we already covered Markdown in the previous lecture, right? You can write headings, you can text, you can images. But the nice thing about like Jupyter Notebook and Google Colab, so this file you can actually download to your computer if you want. So if you go to the file, save this one, download here, download.ipynb, okay? ipynb is the file extension, stands for IPython Notebook, okay? So we have the Python first, and then we have so-called IPython to make it interactive in a terminal, and then we have IPython Notebooks. Notebook basically allows you to run code. You can see the output. So in that way, you don't have to like create a report and just to insert those figures. So think about if you're trying to write a report, right? Using a Microsoft Word document, you have to copy and paste, and you have to like generate some figures or charts using, for example, Microsoft Excel or Google Sheet or whatever, and then insert into your document. This is traditionally what you do. But in terms of Visual Studio Code, you can have the source code, you can have the output directly in here. So everything comes from the source code. If your source code works, you don't have to worry about the figure because it's being generated automatically. So you don't have to manually insert them. And if you scroll down, right, everything is basically a code block, and then you have the output. So here you can also clear the output if you don't want to. So if you look at this one here, you can clear this one out. So this is basically the output of a code block, and you can just execute. By default, upper right corner here it says connect. So when you open the link, you can think about you're just opening a document. It's not, you don't have the Python kernel yet. So connect means you are trying to connect to the server. This right now is for displaying purpose. If you're trying to run the code, then you need to connect. Basically, you need to create so-called a kernel. Kernel basically, you can think about just like a container that you can run stuff in there. Right now, it's not there. It's just to save the resources. So if you don't run, right, you can either click the connect, or you can just click this one. It's going to show you like allocating, connecting. So basically, Google is allocating resources for you right now to run. So take a look. Now it says 0 seconds RAM disk. So if you want, you can click this one. You can look at how much RAM is being allocated and also the resources. 12.7 gigabyte and 107.7 gigabyte. So think about right now you're using a virtual computer. Google is giving a virtual computer temporary 12 gigabyte. It's probably better than your laptop, right? Usually maybe have 8 gigabyte something, 16, but it's pretty decent. It's free, right? So also you have a hard drive, 107 gigabyte. If you have to download a lot of data temporary, this will be a nice way to use. And you can also open another tab, I think, but in order to run the code, you have to log into the account. If you don't log into it, you cannot run the code, okay? Because you need to tie to account so that you can limit like people abusing the resources, because you can spin up a lot of stuff. So here, if I just want to open it like without login, so I can open incognito mode, paste the link, you can still look at it, right? But now if you're trying to like run, so to connect, it's going to ask you to log in. So it's essentially just like Google Docs. If you want to allow people to make edits, right, you can restrict them to, you need to log in so that you can control who have access to the document, okay? And once you are here, then you are welcome to explore and then take a look. So again, we have two types of components in here, either code or Markdown. This only two. So this one here, if you double click the first one or whatever, right? It's going to show you on the left side here. This is Markdown that we talk about. On the right is what it renders based on the Markdown, right? So remember, when we're using Visual Studio Code, right? You write Markdown and then you can preview, right? Remember the shortcut? Control K and then V, right? So essentially it's the same thing here, but in Visual, in Google Colab, it's like this. So you're welcome to make changes. For example, I don't like this one. Okay. Also, by the way, this one right now you're opening. This is a temporary space. It's not saved to your drive yet. So if you make changes, you are welcome to copy this one to computer, or you can just close it, close the browser. Everything will be gone. So here, right? This is heading 1. And if you look at this one here, this is heading 2, right? Matplotlib. Matplotlib is one of the most popular Python packages for doing creating plots and do some visualization. We use that throughout the semester later. But for now, right? Are you familiar with this? Right? So when you have hyperlink, you basically put it in the brackets and then parentheses, put the link. That's it. So this is all called Markdown, and then you can create as many Markdown blocks if you want. You can also up right here. You can move up. You can move down. You can link to this cell, or you can just edit. You can move the new tab. You can delete, right? So those are the basic ones. So if you want to, let's say I want to move this one up, move up, move down, move down, move up, right? In Visual Studio Code, I will also show you later how you can actually do the movement. So you don't have to cut and paste, because sometimes if you want to reorganize the sections, this will be very useful. And again, you can just run through that, run another one, pretty simple. If you want to make changes, you are welcome to, right? So here, right, 1, 2, 3, 4, 5, 6, 7, I can just, if you want to like make changes, here, so just showing you 2 lines, right? So I can simply maybe just add 1 here. I can say, how about this? I want this blue line to go over this orange line. Can I? Right? It's pretty simple. All the points are customized by you, right? So this is 1, 2, 3, right? So number 3 here, this one should be higher. So it will be light one, the lower one. So you probably this one, right? I maybe just change to 7. Run again. Yeah. You're welcome to Kaizen. It's a source code, so it doesn't matter. That this one you can just let the code generate. You don't have to worry about that. And so this is how you can run the code. If you want, you can scroll down, right? Pretty nice. These are the things that traditionally you only use Microsoft Excel or Google Sheets to create. But if you want to precise control how you want to do that, and you want to have some data that you want to customize and also automate so that you don't have to click the button, this would be the way to go, right? So you can generate, for example, if I'm asking you to generate some plots for every state in the US, right? Create a population, the trend of population for every state in the US. Assume I give you the data, right, from 1980s. Every year you get like 1 population, and create those charts for me for each individual state. How long is it going to take you? How long? Alright, 50 states, maybe like 2 minutes, 1 minute for each state. Okay, click open, select the column, and then create the chart, change the label. Right, 50 minutes. If I immediately call, maybe take you 5 minutes to write a call, and then that's it. Everything is automated. You can also save. You don't have to like click. That's the power of doing like coding to automate all the process. So always keep that in mind. Next time if you are doing something, you just click, and you just think, oh, this is so stupid, so annoying. Can I do something better? Of course. If you know how to write code, you can easily automate. There are a lot of things behind the scenes you can do that. But you just go through and take a look at some example, right? You can even do 3D, not just 2D. Pretty nice. So if you are visualizing, for example, vector data, raster data. There are tons of things you can do, and it's nice thing is interactive. So if I'm, I believe if you hover your mouse, you can zoom in, you can zoom out, you can reset, right? We'll show you how to make some maps later. So this is why it's so powerful, because all we need is just a browser. That's it. You don't need to actually install anything. So Google Colab already have tons of packages in here, and once you have this, there are a couple more buttons that will be useful. So the first one here, go to edit, and then clear all output. So if you see here, sometimes you want to start from the beginning to the end. You don't want to see the output first. You want to visualize in your mind, see the code, read the code, and then in your mind imagine what the figure going to look like, and then you can run the code to see the output. So if you don't want to see that, you can clear this one by one. So I'm going to see here, just click this one here. If you click if you move this one, you can click individual output, but you can just edit, clear all output. It's go all in once, and once it's clear, you will see right now it's all empty, so just the source code. Then we can start from the beginning, right? Also, you will see a number in here. If I hover move my mouse out, and you're going to see a number here. You see a green check mark and also the number. Do you know what does this number mean? So if I run again, take a look. Oh, what's the number now? 5, 6, right? You know, right? So the number basically indicate every time you run a code block, it's going to increase. You don't have to like run in sequence. I can come back to here. I can run this one, right? This is number 3. Now if I run this one, it's become number 7, right? I can go back, okay? And it doesn't matter. So there's no sequence. Different from running a Python script using Visual Studio Code. You're running from the beginning to the end. Jupyter Notebook allows you to run like different order. Okay, so you don't have to run everything all at once. This is particularly useful if you have a long running task. Sometimes if the code takes like minutes, you don't need to rerun it every time. So this is also the advantage of using Jupyter Notebook. So, and if there's someone that's very annoyed by like this number, you want to start from 1 all the way to the end, you can. You just need to runtime, and this one I call restart runtime. So there are a couple options in here that you might use. Restart runtime, basically just like you are rebooting the computer. So this is a virtual machine. It's allocated to you temporarily, so you can reboot the runtime if you want to restart from the beginning. So restart runtime. So restart runtime, we clear all the output, clear all the memory. But if you install some packages in there, the packages will still be still there. So basically just rebooting, keep the packages, but clear all the RAM and the stuff. So here, if I click yes, and now if I run this one again, see, it's going to start from 1, right? So, and then you can continue increase. So this is how you use pretty much just write code, write markdown, get some explanation, and then run from beginning to end. If you want to like run all the code, you can just here runtime. You can either just run all, or you can just restart and run all of them, and then it's going to scroll, right? Going through all, you see, it's like spinning, and one of them, it should be pretty quick. Once it's done, you're going to join those plots step by step. So for in the future, if you want to share something to notebook to other people or for lab assignment, it's always a good practice to restart on one time and run from beginning to the end. Because when you are writing code, you're doing the debugging. Sometimes you write a code block beneath, and then you have another variable at the beginning. It might work when you're testing, but if you start from the beginning to the end, it won't work. Okay? So let me show you what it does. What does that mean? So here, Okay, assume that I'm going to create a new block here. So I'm going to put here and then just click the code block. And I can say here, I'm just going to say, okay, x equal to 5, okay. And then you can just press Alt Enter or Control Enter or Shift Enter. So those are 3 shortcuts that you need to probably remember. I think the if you create a new notebook, Alt Enter is usually the one to go. So you execute the code and then move to the next code block. You create a new code block. So see here, Alt Enter, right? The cursor moves down to the next one. Control Enter means you execute this line, this code block, but it stay there. So the cursor stay there in this code block. Shift Enter, it create. Let me delete this one, and then you will understand, right? Shift Enter, execute this one, move your cursor down to the next code block. So if I press Shift Enter, you see it moves to the histogram, right? If I press Control Enter, it's going to stay there. If I press Alt Enter, it's going to create a new block beneath. So if you forgot, I think I put all the video of all the shortcuts in here, so you can go back to the Google site to take a look. Okay, so usually just Alt Enter. If you want to continue to write code and then create that. So next, let me go back to the problem that I discussed earlier, right? So I run this one here, x equal to 5, everything works fine. Then when you're debugging, somehow, okay, I maybe have another one here, code block, and then just print x. Will that work? Yes or no? If I print out x here, yes, right? But you see the variable is defined beneath that. I can still print out the variable. Why?
So that's the last code block you're in.
So keep in mind, everything you run in here, it has something in the memory indicating that variable. So yeah, I can print it out. But if I restart the kernel, restart runtime. Okay, restart runtime is going to clear all the memory. And once the memory is gone, you won't be able to actually run that code. So let me restart the runtime. And you can just restart runtime and run all. So take a look. It's going to start in here. Oh, is it? Let me see here. Print x. Restart runtime and. Oh, because I have another x in here, so I should change this variable to something else, then you will have problem. So I'm going to have x, okay. I run this one, works fine here. And then I come back to here, print x, 3x, and run this one, right? Works fine. Now if I restart the runtime and run all, it's not going to work, okay? Earlier, you always have a curly sign in here that already indicate that something is wrong. If that variable is not defined, you're going to run into error. So you're going to say name blah 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 is not defined, right? So this is the issue that beginners will usually run into. You are running the code, you are debugging, you do all kinds of things, and then you write the code block here, and then later use the variable above. You're not supposed to do that. So you can only refer to the variable, the object, after you define. If it is not defined, you're going to run into error. So the best practice, after you finish your assignment, before you submit the assignment, submit the notebook, always make sure you restart the runtime and run all. If you run into errors, I'm going to run into errors. Okay, so this is how to double check that the logic, the sequence is right. Otherwise, you need to double check and make sure things work properly, right? If this is the case, then you need to go back, okay, because you define the variable in here, you print out this one here, you're not supposed to do it, Then I can come back to here, and then here add a new code block. And in this way, then it should work fine. So this is how you can run code, and then what else? Restart runtime. Okay, there's another one here, run selection, run to focus cell, run after, run before. That will also be useful, because if you have a long notebook, sometimes you want to like start from beginning to run from beginning to your where your cursor is. Then you just run before. If you want to run beneath that, you can also run after. So again, let me clear the audio output. And how about this? Okay, so I have one block, 2 blocks, and they say, okay, I want to run all the code blocks above it, right? So all you need to do, put your cursor within this code block here, and then runtime, run before. So you're going to run all the code block, and then you will stop here. The beneath one will not be executed. Okay, you can also run after. So I will put my cursor here, and they say runtime, run after. So you're going to run all the code blocks beneath your cursor, and then you have all the outputs. So these are some of the common ones that you'll be used. You can also run selection. So basically just the code block. So you can either so for example here, let me clear the outputs. If you just want to run this one, you can either click this run cell, or you can alt enter. Like I said, alt enter, it's going to run, and then use the code block. Okay, anything else? You should also be able to see, if you have your mouse over here, it's going to tell you execute it, right? Let me put you here. Execute it at 10 a.m. like many minutes ago, and this is how long does it take. Okay, so for every code block, it takes some time to execute it. So you can see the time that it takes to execute. So this is how you can run code. Next, let's talk about how you install packages, right? So this is, you can think about this is a virtual computer. It might not have all the packages that you need. So most of the time you have to install some packages. And so behind the scene, do you know what kind of operating system is this virtual machine? Is it Linux, Mac, Windows? Like, where is this virtual machine? You have like 12 gigabytes of RAM and then more than 100 gigabytes of space. Anyone? Do you know what's the operating system of this? No idea? I can guarantee you 95% of all the cloud machine are Linux based. Okay, out there 95%, not 99, but majority of them are all Linux. So this is why you can actually execute all kind of commands on Linux computer, just like you are running that on your terminal. It's the same thing. So first, let's take a look how many packages are installed. And if you want to check that, just go to the beginning and just create a new code block. And so what command do we use to check like what packages are being installed on your computer for Python packages? Remember? If I open my terminal or Anaconda prompt, whatever you like, how do I check what packages are being installed? Pip list. Exactly. It might take some time to list all the packages. You can do the same thing coming in here. Just pip list. And then shift enter. And this is a log of packages, so it might take some time. So scroll down. I'm not sure, hundreds of packages are already pre-installed. If the packages that you want is not there, you can install by yourself. So this is one way. You can just pip install, but usually recommended you want to put an exclamation sign at the beginning. It's the same thing, but exclamation just to tell Google Colab that it's a command line. It's not Python code. Okay, to avoid confusion, right? So now if I put a exclamation, if I don't put that, it's going to show you maybe. Anyway, you see curly lines. So this is actually not Python code. This is command line. This is called base command. So if you run this one, you want to get the same result. Okay, so this is how you can and you can use all kind of the Linux, most of the Linux command line, you can actually run it in here. So for example, you can download a file, I can get something to the computer. So on the left side here, if you click this one, there's a icon here. So you can think about this as a temporary space. You can store all kind of files in here. You can upload a file, or you can download a file from somewhere. So you can download a zip file, download any file. You can think about this one here is a directory that has over 100 gigabytes of storage. So you can put all kind of temporary files in here. And so next, let me show you like how you can actually clone the repo to this space, right? So if I maybe just use leafmap, if you want, you can go to here. I just going to go to leafmap, right? So this is the leafmap repository. Assume that you are running right now in Google Colab. You want to pull some stuff from GitHub. The easiest way would be to open the GitHub and then just open any repo. Then just click the URL. Okay. And come to here. One thing you can check is whether you can run Git or not. So I can just maybe Git. You see? It's already Git is already installed on here. So if you want to clone a repository to the Google Colab here, how do you clone a repository to your computer? Using the command line. Git clone, that's it, right? Git clone. So we can do the same thing. Git clone here. Control V. See this one? Exclamation clone. And pay attention to the left side here. Google Colab shows you some sample data, but we're going to clone something to our computer. So just click here and take a look. Clone. Blah blah. It might take some time. 100%. And then it should not take too long. Then on the left side here, you should see that one updated. It might be the repo sometimes it's too big, but you have to keep in mind this is virtual computer. The internet that you are cloning something to this one is many times faster than you are downloading something to your local computer. If you're trying to download like gigabyte data, this one is very, very quick. So I'm not sure it's why it's still 412 megabytes, so it's pretty big. So but it's downloading the file and then unzipping. But on the left side here, you should see the files right now. I probably need to compress the repo. Right, it's done. Then on the left side here, see you have all the files. Right, so you get the entire repository to your GitHub. Again, this is temporary. It's not to your account. So if you close the browser, everything is gone. So it's just a temporary space. Then go to, for example, examples, notebooks. You see, I have tons of notebooks actually in here. So maybe just click. And this one right now just showing you here. It's not actually a notebook is not executed yet. So you can, one thing you can do, you can copy this one to your drive because by default, Google Colab does not, even if it's an iPad MB, Google Colab does not recognize that as a notebook. So I'm going to show you the differences, how you can actually, next time if you click this one, it will open the Google Colab, because right now if I click, it's going to show you here, not fun because it's just like plain text. It's not a notebook. So one thing you can do, if you want to do that, you can just copy this one to your drive, and it's going to create a copy. Now, you see, yes, this one is allow you to run the code. You might be wondering where exactly is this notebook? Oh, not this one. Oh, this one is basically the one that we're using earlier, but this is where it's being, let me see here, file. I think it's locate in drive. So if you copy any notebook to your computer, if you want to find out where it is, just click, not to your computer, to your Google Drive account. So everything is can be saved to your Google Drive account. So if you click locate in drive, and it's going to open your Google Drive. Then it's going to show you. So if this is the first time you're copying, Google Colab will automatically create a directory under your Google Drive. So you should see Colab notebooks. Can you see that under your account? So basically you're creating this one. So every time when you're copying something, it's going to coming up in here. And if you look at the notebook, the icon in here, it's going to show you like this icon. So that means indicate it's a Google Colab. Or if you want to create a new one, I can right click, more. Oops. I think the screen is too small. So more. Do you see Google Colab in here? If it doesn't, then you might need to click more apps and then type Google Colab. So then you saw me here. So basically, this is basically just like create a Google Docs. Right click and then, but this allows you to create a Google Colab notebook. So if I click this one here, right, then you're going to create a new one and untitled. So from here, you should be able to install packages, write markdown, execute source code. So it's very similar to running it on local computer. I'll show you how to run it on local computer. But for now, this install package, for example, I can just write exclamation. How do I install a package? On your local computer? Using pip install, for example, leafmap, okay? And then Alt Enter. And this is how you install all kind of Python packages. If you have more packages, you can just write in here pip install leafmap space and then another package space another package, so you can install all kind of packages. But you have to keep in mind this is a Linux computer, so not all the packages support all the platforms. So if you're trying to install packages that only support Windows, you won't be able to install in here. But leafmap support all the platforms. And for the package that you're developing, usually if it's not that complicated, you can make it work across platform. So you see here, it takes some time and then it's done. If you don't see any warning messages, any red color text at the end, that means you're good to go. You can start using leafmap. But if you install some packages that are a little bit complicated and you have some conflict with some of the existing packages, at the end here, it's going to show you some error that blah, blah, whatever. Then usually it's the best practice to restart the kernel. So you can just do here, restart runtime, and then restart runtime. So that's usually just like after you install a package on your Windows computer, you need to reboot your machine. Same idea, but not always the case. Some complicated one you need to reboot, some easy one, this one, leafmap, you don't have to. So, and also, pip install, you only need to run it once. You don't need to run it multiple times. If you run it multiple times, for example, I can run again. It's not going to install again. It's just going to show you requirement already certified, blah, blah, blah. That means it's already there, so I don't need to run again. And if you download this one to a computer, make sure you comment out this one. Otherwise, keep running every time you run a notebook, you trying to install it. There's no point. So, yes?
So when you're installing the different packages,
Mm-hmm.
what is your environment, your entire virtual computers, and that package available on your entire Google Colab or just that file?
Just this Google Colab. Just this notebook. So if you create a new notebook, this is not available. So it's only within this document. Every notebook is a virtual computer. So if you're trying to open a new one, new Colab, unless you're using the same thing, but if you create a new notebook, it's an entirely new virtual computer. And Google, I think limit like 2 to 3. You cannot open too many instances. So this is called one instance. So basically, you're spinning up one virtual computer. And once you have done this, then you can start. For example, I can say import leafmap. Okay. And again, just comment out this one. Control/. That means it won't. Next time, if you restart runtime, it won't check that again. Okay. So install leafmap. Okay. Import leafmap. Right. Import the library, and then I can say m equal to leafmap.map, and then type m, basically just to display the map, and then you should have this map right nicely. One line of code. Then you have the map. You can zoom in, you can zoom out, you can draw something on the map. You can rectangle, Okay, and I can clear. I can change the base map, for example, upper right corner here, click, and then the first icon, for example, select this one. I want to change it to maybe to Google Satellite or Hybrid. See, pretty quick, right? And you can change to, for example, lane cover. Right. And so this will be something that you can use an example. So your Python package at the end, you can have something like this. So you can build on top of whatever already available. You make it easier. And besides this, I can also, for example, here I can change this one. I can change the layer opacity. Take a look. Right, pretty nice, right? Of course, this behind the scene like 100 lines of code. It's not that easy if you want to make it compatible with all kind of data layers. But just to show you an idea, like this is how you can install packages. So after you're done, I can restart one time, restart and run all of them, just to make sure everything works properly. Again, don't try to install the packages all the time. Next time if you open it, then you have to reinstall. So how do you, for example, if you close the tab, most likely you're going to stay there for a couple minutes. I'm not sure how long, but if you want to completely delete that, you can just come here, runtime, disconnect and delete runtime. So essentially this tells Google to destroy the virtual computer. And next time when you open, you have to install again. So how about this? Let's close this one. And now if I open again, or this one here, I'm not sure if it's still there or not. It might be. If it's not, then you have to install. Okay, looks like still there. So if I run this one, you see, it still works. Okay, I run this one again. So, but it's only there temporarily. If it's like idle for too long, it's going to be gone. So here, if you want to try it out, for example, runtime, disconnect and delete runtime. So if I do this, and then I close it, leave. Okay, I double click, open it again. You see at the end of this one here, this one is usually changing. So if I click this one, you want to run into errors because the computer is already deleted and it's no longer available. And this is where you need to install the packages again if you open a new notebook. So again, come back to here, very simple, Control / and then run this one again. And after you finish the installation, comment it out, and then you can start running all kind of codes. So this is how you can create a new notebooks and then start running code. Later, when you develop Python package, you can also have links to Google Colab. So next I'm going to show you how you can put some things on your website and then you have a link so people can directly open your notebook and then start running without having to like download it and then upload it. It's not very convenient. So what you can do, again, I can just go to leafmap.org and I can show you here. And if you look at the web page, right, you can see here, open Google Colab, open Miner, Studio Lab, right? I can allow user to open it and then just run my code without having to go through a step. So, or alternatively, I can have notebooks and then leafmap intro. Right? I also provide 3 icons in here. So if you click, for example, right click, open a new tab. See that? It directly takes user to the notebook. And if you look at the URL in here, colabresearch.github.com, and then this comes from GitHub. This will be the username. This will be the repository name and block master, and this will be the directory under the repo. So later when we develop package, I'll show you how you can actually do that, but it's actually pretty simple. So all you need is just the URL to your repository. Another thing, another shortcut that would be useful is that, so let's go, for example, to any GitHub repository, and as long as it has some notebook examples, so I'm going to, let me go back to my example in here, just to show you like how you can have a quick shortcut to any notebook example. So I'm going to maybe use leafmap again here, and then examples, and from there, notebooks. Alright, so I'm going to click this one, pay attention in here, right? So this is notebook opening in GitHub. Does it allow you to run code interactively on GitHub? On this page? Can you run it? Can you? No, it's static. It's just like HTML. It's just a web page. You cannot run the code like Google Colab. So assume that you are navigating. You look at some GitHub repository. Okay, it look fine. This one's so interesting. I want to try it out, but I don't want to install it on my computer. So what do? Assume that right now you want to try out this notebook. Right? What kind of options do you have? You download it, right? Right. So let me show you the not so convenient way. So you can go to raw, right? And then this extension is the repo, the notebook. Save as, download it to my computer, and make sure that you change the file extension. By default, it's going to .txt. Well, you're not using txt, so you have to just here. Let me do it again. Right click, save as, and then all files. Then remove the .txt. You don't want the .txt, right? And here, done. Now you have this one on your computer. Okay. Then you can open Jupyter Notebook or Jupyter Lab or Visual Studio Code. If you want to run it in Google Colab, you come here, go to Google Drive, and then from here, simply drag and drop. But still, it's not like convenient. So pay attention here. Do you notice any differences between this and this? It's just like a book. Okay, it's not being recognized by Google Colab as a notebook. So if you're trying to open it, you can open. But if you share, I think if you share this link to someone else, they won't be able to actually see that. So if I copy this link, and then if I open incognito window, paste this one, can they see this? Oh, because it's not shared yet. So let me click here, share. Also, make sure that if you're trying to save the link to someone else, make sure that it's enabled. Otherwise, people won't be able to actually open it. So share anyone's link, and then done. And then I can try it again. Open, paste. Okay, then now they can see this one. So, but usually, let me close this one again. You still see it's not being actually recognized. So if you're trying to upload a notebook to Google Colab and you want to have like an icon, you have to open it and then just click, or here, file, save a copy in Drive. So this might looks a little bit not very straightforward. It's already in my Drive. Why I want to copy another one? So if I copy this one, you will see the differences. And now I'm opening a new one, and it should come up with another one here. Copy. Now you see the icon, right? So basically, now this time it's being recognized as a Google Colab file. So if I open directly, you want to do this way. So this is how you can download something to your computer, upload it to Google Colab, and then just make a copy. Then you can share this one with anyone. Okay. So this is one way. Not very convenient. So next I'm going to show you another way. So it's again, go to my let me go back to here. Okay, assume that you are navigating Google Colab and you find some notebook very interesting, but you want to quickly move this one to Google Colab. The easiest way, I already provide the icon here, but not all notebook provide the icon, so you won't be able to do it. So one way you can do is come here at the URL, here, GitHub, and then the URL stay the same, but you type to Colab. Okay, so this is a nice trick that is going to save you some time. So github.com, right? Just GitHub to Colab.com. Everything else remain the same. Can you type this one? To Colab. So github.com, after the GitHub, just type TOCOLAB, and then just press enter. Take a look. Now you navigate. So it basically transforms this one to Google Colab. So you don't have to copy and paste. If you want, then you can just copy to Drive. Then this one will be copied to your computer. So if I click this one here, copy to Drive, and it's going to open a new one. Then you should see somewhere in here another one popping up in a few seconds. Did it come here? If not, sometimes you might have to refresh or copy all one in here. It's already in here. So this is the easiest way to get a notebook and then to run on Google Colab. So now if I come back to here, you can start thinking about this, right? So the notebook, when you run your notebook, make sure that you install the dependencies if it is not already available on Google Colab. Just like the virtual computer already have a bunch of packages, but it's not going to have everything that you need. And so all you need, come here, Control/uncommon, run, and then you can start executing the source code so they can try it out. And this is how you can also make your packages available to other people. You can have a badge on the notebook that allow people to actually do that, but you can also just use this shortcut if you want to try it out by yourself. So this is how you can install the package. On the right here, you will see every time it's going to connect, get a new virtual computer, and it's going to install, and everything else remain the same. So those are the same steps that you can do. I think there's another one. Let me see if it still works. So let me go back to here and try another one. I think there's one called 1 second examples. See here, notebooks, and or maybe this one here. I think it's called GitHub 1S, if I remember correctly. It's going to open as Visual Studio Code. So if you're interested in using Visual Studio Code to see the repo, you can do it this way. So again, GitHub.com. Earlier we used GitHub, right? GitHub to collect. It's GitHub 1S, 1 second. It's going to open the repo as Visual Studio Code. So in that way, you have you don't have to download that one to a computer. So you can, if you are what's they called, Visual Studio Code user, you can do the same thing. So you get the same experiences. This is way better than just using. You have to use GitHub. Sometimes it's a bit slow. So this can provide some way if you want to look at the source code. But this one is not officially supported by GitHub. So all the GitHub to Colab and then GitHub 1 second is not officially provided by GitHub. So it might stop working at any time. But at least these are some of the tricks that you can use to quickly load some stuff into Google Colab, and then you can try this one. Okay, so GitHub 1 second, GitHub to Colab. So those are the two one. I think I put in the somewhere in here. Common, yeah. Replace GitHub.com with GitHub to Colab, or replace GitHub.com with GitHub 1 second. Then you should be able to do this one. Okay. So this is how you can open notebook in Colab. And there's another one here. So this is so-called the base. The base allows you to put an icon on your notebook or on your Markdown, so that other people can navigate to your website. So just like what I did here in this repo. So I can put on a base in here, so people can just click and then can try it out. So if you really want to make something easier for the users, you should try to lower the barrier. So this is what you can do, right? So it's one click, load it up, try it out. You don't have to install any single computer. Everything just works perfectly. So this is where you can put the base. All we need is just simply copy this one here. Let me show you here. I'm gonna copy and assume that I have a new notebook in here, right? I can just create a new text code block and then just paste this one, just like what I show you, right? Now you see the icon, see this one? And this is where you can make changes to whatever notebook you want the user to navigate into, right? So if you finding, let's say, okay, you have a GitHub repository here and you have a notebook, let's say examples, and about the notebooks, about maybe legend. Okay, so assume that when user click that icon, you want to open in Google Colab. So the best way would be once you open this one and then github.com, you want to GitHub to Colab, and it's going to redirect to this URL. Alright, so here then I can copy this URL and then come back to, where is it? Come back in here, then you replace this one with your URL. Okay, the icon stay the same, but behind the scene the link is changed. So now if I click this one, take a look. Right, like legend. So this is how you can put this one on your repository and then just have this URL. Then users should be able to easily find your stuff and then run that. Okay, so open in Colab, so exclamation, the square brackets, and this is the parentheses, the link. Within the square brackets, this is, instead of text, right now you are putting on an icon here, open in Colab. So if you don't like it, I can say just like open in Colab. It's the same idea, but just like better rather than hyperlink, right? So we can put something inside the brackets to have an icon. So all this is also called pages. You can put as many as you want. And so later, once you have the package, right, you want to develop a website. So on your homepage, this is where you can put all kind of pages, allow users to try it out. So just one click. So I can open this one, open. There's another one here called Jupyter Lite. We don't have time to cover it yet, but Jupyter Lite is another fantastic resource that you can utilize. And you see, this is a Jupyter Lab environment. You just open it, and it's an HTML. So last time we showed you how you can like upload HTML to your personal website. You can just create HTML and then user go to a website, you can let them try out. And the nice thing about this, it doesn't require a virtual computer. So it's just a so-called static website, and people will be able to run your code and then install the packages without any computer resources. So you can open in your Google, in your cell phone, you can still run the code. So everything works perfectly. So here, let me show you, like I can do notebooks. I can try out the first one, for example, div map intro. You see, the same, pretty much everything the same, except that when you're trying to install packages, this one use like percentage sign and then install. So I can show you here. Again, you can look at this one here, the UI index.html. So it's a static website. You can run it anywhere, pretty much. And this makes things scalable. So think about if you're trying to make something that can be used by 1 million people. If you're trying to set up some resources on Google and Microsoft, it's going to cost you tons of money. But this one, $0. Just host it on your GitHub pages, send the link, everyone around the globe will be able to access it. GitHub will handle the rest because GitHub is the server provided for you to free access. You don't need any computing resources. So this is the way that you can teach thousands, tens of thousands of people without spending a dime. And look at it, I install, nothing happens. Then you can think about here, I just execute. It might take some time when you first time when you are importing, but after that, you should be. It doesn't support everything yet, but some of the cool stuff, I mean, you should already install, right? So here I can zoom in, everything remain interactive, and you can change the base map if you want. Right. So Jupyter Lite is basically a lightweight version of Jupyter Lab, but it's a static. It can be deployed anywhere. It's just a simple HTML website. There's no database. There's no computing resources. It all based on your local computer. So if you have some resources, you can run that. And so-called scalable, reproducible. This is what this means. Scalable means you can tens of millions of people can use it at the same time without using your computing resources. And reproducible means everyone get the same results. So if I provide the source code to you, you run, you get the same results. So everyone is using the same environment. In the traditional way, you are doing things using ArcGIS. All the computer are different. You click, you want to generate the map. You're trying to put it in another computer. How do you make sure that other people generate the same map as you, exactly the same? Can you do that? There's no way. Human is going to make all kinds of different errors or different modifications. You're not going to get the exact same thing unless you tell exactly the step. But for coding, it's easy. Everyone wants the same code in the same environment. Everyone get the same result. So this is how you can make things so-called reproducible, if you want. Okay, so this is some of the tricks about using Google Colab. Again, install packages, pip install, exclamation, pip install, pip list, check the packages, and then just create a new runtime, run the code, restart runtime, run before, run after, and then copy the repo from GitHub to Google Colab. And again, everything is temporary. But if you want, let me show you in here. I forgot to mention earlier. Right, you need to create. Right now it's enabled, and by default, it's only in here. But you can actually access file from a computer. So this is how you can actually utilize the so-called cloud computing for free. Think about you have some files on your Google Drive, and you want to read it. You want to read the file from your Google Drive, so that you don't have to like download and so basically here, how to access the file from your Google Drive, so that you can open it, you can read the data, assume that you have some vector data within your Google Drive. So let me go back to here, under my Google Colab, maybe another folder, so I can create a new directory. So here, I already have some data in here, but it's nothing fancy. So here I can maybe download CSV. So just to show you the procedure. So I'm going to download data. Do I have any CSV somewhere here? For example, state CSV, okay, and then raw, okay. I'm going to save as. I'm going to download this one to my computer. So this is a CSV file. It doesn't matter what file it is. Again, just an example. So I'm going to drag this one to my Google Drive, okay. So the file is already in here. Now I'm opening. I'm in Google Colab here. Is this one? I opened too many. How about this? Let me open this one again. Okay, it still works, right? So what you can do, look at this one here. Click this icon, mount drive. So as I mentioned earlier, this is a temporary space. It's not connecting to your Google Drive. So if you want to, it's just mount drive. It's going to create a new code block in here and dismiss. So all you need is just to run this one and then connect to Google Drive. You might need to log into your account and then click OK. Allow. Then you should be able to see this one popping up in here. Then you have access to a Google Drive. So in this way, you can read data from Google Drive. You can also, excuse me, save data back to your Google Drive. So this is way powerful because you can open a Google Colab and it just let the code run. And if you need to generate data, you just save the Google Drive. When it's done, you just close it, all the data within Google Drive, and then you can just copy things back and forth. So look at this one here, Drive. Now I have access to Google Drive. If I click this one, you should see my Drive, right? Data. Oops. See this one, right? Then if you click here, how about my mouse? Copy path. So once I have the file path, now I can actually access the file directly within Jupyter Notebook. So I can show you here how I read the file. You don't have wide web right now, but I'm just showing you that it's possible. So I can see here by import pandas is PD, okay. Then I can read the file, I can show the content. So you'll be pd.read CSV. You should have the autocomplete. I'm not sure it's not showing up. And then Control V. Take a look at this is the file path right now to your stuff, and then we run it. See that? Okay. And you can also save file back to your Google Drive. So I can say maybe this one is a data frame. So df equal to this one, and then I can say df. Okay. Display the file, and then do some manipulation. So for example, you can do some selection, whatever, and assume that this is the result you want to save back to a computer. So I can say df dot to CSV. Why so slow? Okay, right. And now I can create a new file names. Okay, Control V. Okay, state. And so this one I will say state new. Okay, Shift Enter. All done. On the left side here, refresh. See that? And if you come back to Google Drive, see the file? And this is how you can read the file from your Google Drive and do some processing, save it back. Okay, and in this way, it's much faster because if you're doing things on your local computer, you are basically saving file to the network, so it include a lot of network transport, so it takes time. So think about here, if you're processing a gigabyte of data on Google Drive, on Google Colab, I can easily save this one because it's in the Google Cloud. It's so fast, so saving 1 gigabyte data to here, it probably takes less than a couple seconds. If you're saving your file on local computer and then save to Google Drive, it's going to take you many minutes. So this is what I usually do if I need to do a lot of data processing, and then it's very slow because you need to download the data and then to move data back and forth from here. This is Google Colab is so fast. It's gigabytes internet, so it's very nice for downloading large data set. So maybe see if I can show you some examples. How about this? Let me find one. See if I can find some large data set. How about this? I think I have an example. Let me go here just to show you like how fast it is. Maybe div map. Okay, and so notebooks, collaborative my GeoTIFF. So I know there are some large files in here. For example, this URL. Okay, copy here. I just want to get the long URL so they can showcase how fast it is. So this is the URL. Okay, copy, paste. So if I press enter, it will show you. I can download this one to a computer, and then just see the lower left corner. See how long it takes. 2.9 gigabyte. 2 minutes left. It's going to take a while. And now let's come back to here. Google Colab. It's probably much faster, but I'm not sure how fast it is. But you can show here. Now I can just use. Okay, so you're going to download file from the internet to Google Colab. Easy things would be just wget. You can just double. You see here, right? It works. And just going to Control V. So wget basically means you can get anything from the internet, download to the drive. So now you can see the speed in here. How fast it is? Like 64, estimated like 20-30 seconds. So it's going to hold up faster than you are downloading something to your computer directly, because although the file comes from the same server, but Google Colab has like huge cable, right, connecting to the wall, and it's going to much faster, especially if you're downloading something from the US government, because they are already in the cloud. So it's going to be a whole lot faster. Of course, I already canceled this one, but this is going to take you like a couple minutes. That one should be pretty quick, right? Gigabyte of data, and again, you have over 100 gigabyte of data storage in here. You can download anything to here. Once you finish this, you can transport this file to your Google Drive. So next time you're trying to download tons of data from the internet, think about this one. Rather than download things directly to your computer, just use Google Colab. Write some command lines. You can do the looping, and then download files to. You can specify files pass directly to your Google Drive. So in that way, you don't have to download this temporary space. You can push things directly to your Google Drive, and then if you need to do processing, you can just retrieve the file from your Google Drive. So in that way, you don't have to keep like uploading and then managing, because the Google Colab, the virtual computer, the resources, the configuration that you're having here is probably better than your laptop. Okay, right now we're only using CPU, but they also GPU, right? So if you are doing machine learning, deep learning, this is going to help you. I'm not sure if your laptop has GPU, right? If you want, I can here runtime, and there's one here called change runtime type, GPU TPU. So this is especially useful in the data science, machine learning, artificial intelligence. If you need to have access to GPU, this is the way to go. So you don't have to install things on computer. It's just so fast. But this is limited resources, so you might have to wait. But usually there are tons of, you can just change it and then save it. You might need to restart the kernel and then essentially, okay, you see, everything is gone. You create a new runtime. Would you like to terminate the previous runtime? Click yes. In this course, we're going to get into we won't have time to get into detail how like do GPU and other stuff, but again, try to utilize these free resources. It's going to help you, especially trying to automate stuff. And if you're running things, for example, take like hours, you don't want to consume the energy on your computer. You just use this one, download stuff, do computation, save stuff to computer drive, and once it's done, everything is on your drive. So I use this to process like terabyte data. Because I have download, for example, I need to download all the DM for the US, 10 meter resolution, like hundreds of files. And then I need to process each DM individually. I need to do something. I don't want to save like terabyte data to my computer. All I need is just open a Google Colab, write some code, do the processing, and then just export the final result only a couple megabytes to my Google Drive. And it will run overnight. I don't have to worry about it. But Google Colab does sometimes like check you whether you are running like long, if you're running like for too long, you are occupying resources, they will kick you out. So you just to pay, make sure. But it's a very nice computer resources that you can utilize to do open copying. Especially if you're outside, you don't have access to personal computer, you don't want to have any private, but you still want to practicing, just open Google Colab and then just start typing, running. You can spend some time just to explore. So again, Google Drive, and then you can refresh, you can upload files. Other than that, those are some of the key stuff. There's also a terminal here if you want access to the terminal. Just like on your local computer, you open the terminal. So because this one is a virtual computer. So if you click here, oh, this one you need Google Colab Pro. You don't need to pay. So, but you can also have some command lines and other stuff. Okay, so that's pretty much about Google Colab. Again, try it out and utilize that. There's some other ones in here we don't have time to cover. So the second one will be the Amazon SageMaker Studio Lab. So all the Microsoft Azure notebook. And there's another one called Binder. Binder is kind of similar to Google Colab, but for this one, you have to enter your GitHub URL and then the link to the notebook so that it can open. But the nice thing about this, it doesn't require a login, so you don't have to log in. You just open it, you're able to run it. The downside is that it doesn't have that many resources like Google Colab, so the RAM and the storage you're going to get is much smaller. So if I open this one, it's going to tell you. So here, just to show you like what this one is about. Is actually right now, when you click the link, it's going to create a virtual machine for you, but it's going to take some time. So unlike Google Colab, when you click, it's instant. This is not, this is free resources. So it's going to take some time for you to, for them to get the computer ready for you. But nice thing, it has nothing related to Google, so they don't check your privacy. So you can also use this one for training, for workshop, that you want the audience to have the same environment, because this one you can have full control. You can also install packages, pre-install packages. Unlike Google Colab, everything is temporary. When you close, everything is gone. And you need to install packages all the time. For this one, you can get from the repo, it will automatically install the packages. So the user don't have to install, for example, libmap or other. You can, in your repo, you just have a requirements.txt, and then you will set up the environment. So this is also another way that you can utilize. So at the end of your package, you can do both. And I will show you more examples later how to do that. Okay, so that's all for today. And make sure you try it out, practice. And we'll see you on Thursday, okay? About using Visual Studio Code and also Jupyter Tab on your local computer.
Because it stops right here. I just want this to be like centered on the page.
Yes.
I have a quick question.
I do this.
I was doing like my website and everything. I got it all good to go, but when I was trying to do the like templates, I did one and I didn't like it, so I took it off and I put another one on, and now it's telling me to merge my branch. So I tried to do that, and
Do you pull
That
the?
was a pop-up, do it kind
Need to pull.
space.
So that means something
It
is
does-
wrong.
yeah,
Yeah,
it
you
does-
need to terminal.
Oh, is that? So you look at the size like this?
Please commit changes. So you undo the commit.
961 is for that top server.
So do you make any changes to the? So the reason for this is
Yeah.
basically whatever things you push to GitHub is there permanent. So if you on a local computer, you need to make sure that you don't have some conflict, because if you're already there, you make some changes, you don't like it, you delete it,
yeah,
you're missing the history, missing a piece.
okay,
So and then GitHub doesn't know like what do you do,
That's what I.
Okay.
because it's basically all the steps need to be doing. And one thing, I mean, easy way would be to you can delete the repo, you can clone the one from your repo again, and then everything we the same we sync with GitHub. Or you can also have a reset. I think you can. So let me show you here. One cheese. Open this one. Is this your website?
yeah, the H.
Yeah, so here, it'd be easy to just copy and then clone this one again, delete your existing one, then it will be synchronized.
Maybe it is
So
the
in that
body.
way, you are getting the same.
Maybe we make the body the same
Going to click this one,
the whole way throughout.
then where is this one
So you're saying
located?
like this whole section is different?
Documents, and then, oh, this one?
Yeah.
So then, for example, here, you can temporarily change this one to another one, and then just, oops, this is being used. And then just clone it again. But Git also has code that allow you to reset, but I think this would be easier.
You guys trying to fill the edges there.
Mm-hmm.
So if I have the same thing.
Is it empty?
What, just to get rid of this indentation over here?
Yeah, okay. Well, so I just put it next to the background that filled it in.
Yeah, I think it's the same like
At least access the.
the OneDrive problem. So you need to make sure that you clone that to your computer, and then you can start making changes. So basically, sometimes if something doesn't work out, just remove your folder on the computer and then just clone the from GitHub again, and then it should work just fine. Yeah.
Thank you.
Welcome.
CSS with the markdown. Yeah, so this is the identifier for this one is, it's a container large. So if you put that entire title in and then put whatever you want in that